Today we are working on solving equations with cubes and cube roots. Okay? I want to take you there slowly so that you can recognize when we actually get there that you already know how to do this. Not because we've ever done it before, but because you can use prior knowledge to figure out what to do in the next step. Okay? And when I say slowly, I mean really slowly. Like, we're going to start here. X plus 5 equals 12. Do you know how to solve this equation? Then please tell me the first step.
Subtract 5 from both.
Good. Subtract 5 from both sides. When we subtract 5 from both sides, we get x equals 7. Is that the correct answer?
Yeah.
How could we know for sure?
7 plus 5 equals 12.
Yeah, substitute it back in, right? 7 plus 5 equals 12. That's correct. Okay? Would you know what to do if the question said this? X squared plus 5 equals 12.
Subtract 5.
Okay, so if we subtracted 5 from both sides, I would get x squared equals 7.
Then you square root.
I could square root both sides because I'm trying to undo a squared. And the way I undo a squared is taking the square root, right? So on the left-hand side of the equation, I get x. And on the right-hand side of the equation, I get
Square root of 7.
almost. Almost the square root of 7. When we did this the first time, you forgot this too. So I'll forgive you a little bit. Okay? Remember this?
Yeah.
Plus or minus the square root of 7? Okay? So could you do it if we were here? X cubed plus 5 equals 12. Could you do that problem? Okay, so if we subtract 5 from both sides, I would get x cubed equals 7. How do you think we would undo a cubed?
With a cube root.
We would take a cube root. That's exactly right. Cube root there, cube root there. What is the cube root of x cubed?
X.
X. Do you know what the cube root of 7 is?
There.
No, me neither. So we're just going to leave it just like that. There's no reason for us to punch that into a calculator, even though I could if I needed to. If it was a word problem that needed a specific length or a specific height. This isn't. This is just a naked problem. There's no meaning to it. It's just teaching you how to do the problem, right? Teaching you how to do the steps. So the cube root of the cube root of 7 is all we need to write. Okay?
You don't need the plus or minus.
That's a good question. We need to talk about that. Do we need the plus or minus?
No,
Why not?
because it's cubed.
Because it's an odd root.
Uh,
Okay? It's an odd root. When we take odd roots, we don't have to have the plus or minus. When we take even roots, like a square root, we do need the plus or minus. Okay? You okay with that? Could you do it if it was like this? X, or let's say the square root of x plus 5 equals 12.
subtract 5.
Okay, we could still subtract 5. We're still subtracting 5 the same way as we did before. So we get square root of x equals 7.
You square it.
So I'm trying to undo a square root. So you're saying I should square it to undo that root?
Yes.
Good. What is the square root of x squared?
X.
X equals 49. Is it right? Yeah, I forgot to do those on those two. You did that in your head, didn't you, though?
Yeah.
Oh, of course you did. Okay, let's check, though, for sure. Square root of 49 is 7 plus 5. Is that right? Okay, let's check these just to make sure. The cube root of 7 cubed.
7.
The cube root of 7 cubed.
Cubed. 7.
That's 7, right? So 7 plus 5,
It's
12. Okay, what about this one? Positive square root of 7 squared. 7 plus 5 is 12. Negative square root of 7 squared. 7 plus 5, 12. Okay? So the point I'm trying to make here is, should I ever get any of these wrong? No, because I can always check them, right? Okay? So could you do this one? Excuse me.
Same thing. Cube.
Same thing. Subtract 5 from both sides. Cube root of x equals 7.
Cube it.
Cube it. Okay, so the funny part is when I was having this discussion earlier. Wait, did we have this discussion here?
Yesterday about cube.
Yeah. Okay, good. I don't have to worry about that then. All right, cube. So the cube root of x cubed is x, and 7 cubed is 343.
Oh, you got it.
Well, I did it last period too. So, but thanks for thinking that I could. That was nice. Okay. Questions? All right, one more for you. X to the 2/3 power plus 5 equals 12. Subtract 5 from both sides. X to the 2/3 power equals 7. How can I get rid of that 2/3? That's exactly what I need to do. I need to multiply it by if it was flipped. So what am I multiplying it by?
3 over 2.
Okay, so instead of saying flipped, which is a perfectly fine word, but there's a little bit better math word, what would that word be?
Reciprocal.
Reciprocal, okay? What am I multiplying by 3/2? The exponent, right? So do I multiply this 7 by 3/2, or do I multiply its exponent by 3/2? Its exponent, right? 3/2. So this ends up being 6 over 6 when I multiply it, right? What is 6 over 6? 1, which is what I needed it to be. 7 to the 3/2. Do you know what that is? Okay, I want to show you two things. First of all, this is not wrong. Depending on what kind of test you're taking, if it's a free response test and you get this far, I'm not taking any points off of that. But what if it's a multiple choice test and this is not any of the choices? Don't tell me you would just punch them all in the calculator and see which one equaled. What you got? Oh, no. Okay. If you'll remember, the top in a fractional exponent, the top is the power and the bottom is the what? The root, right? So what does that mean? What kind of root is it? A square root.
And then the 3 is on top.
What is 7 to the 3rd power?
Square.
343. Okay?
Cool.
I may even give you extra points for going this far. Okay? But if it showed up on the multiple choice test, it may show up like this, and you've got to know these two things are equivalent. Fair enough? Okay? So looking back over these examples for today, which ones do you think were our lesson examples? It actually wasn't. You've already done this before. These two. These are what our lesson is today. Cubes and cube roots. Okay? So why in the world would I give you 6 examples that were almost exactly the same? What am I trying to get you to realize?
It's all the same.
If you can do one of these, you can do all of these, as long as you remember when you get to this point, what do you do with that exponent? How can I undo that exponent? Or how can I undo that root? Okay? Just because some other classes have come before you, let me show you some things that they were kind of getting tripped up on so that you don't get tripped up on as well. Okay? If this is the problem, what do we do first? Do we take the cube root? Because that's what they were kind of wanting to do.
Divide it by 2.
Why do you have to divide it by 2 first?
Because you have to get the x by itself.
Yeah.
What is being raised to the 3rd power?
The x.
Just the x, right? I have to get the x by itself, so I have to divide by 2 first before I can go on. Okay? Does that make sense?
Yes.
Okay, so just be real careful of that. What if it's even like this? This was something that may show up. If it was like 3 cube root of 5x equals 12 or something like that. What do I have to do first here? What's the 3 doing to that root? Yeah, I have to divide by 3 first. Then what do I have to do? Divide by 5?
No, you do the
Why can't I divide by 5?
cube because it's
The
so
5 is inside that root. I got to
Yeah.
get rid of the root first before I can get in there to mess with the 5. Does that make sense? Okay, any questions about that? Any questions?